Welcome to another practice model dated March 6, 2024. This is a slide stop from Too Tall Toby's practice models. This is going to be performed in IronCAD. And some of the key notes about this model, it should be fairly simple to do in IronCAD. We have standard shapes for a lot of these elements, like the slots and the blocks that you see here. However, we have an angle that's defined. We know a depth or length of this from the center point of our slot that references this 105, which is a critical dimension because you don't know the depth of this boss here that's coming up. You also have a draft face here that has a reference on this extrusion height here of 14, so you have to draft from there in the back. So you can't do that from an extrude because you have only three faces that are drafting on all four because the front face is straight. So we'll have to show you how we'll handle that in IronCAD. And then we also have to place these holes, which are, non-planar faces here in both of these cases. So we'll show you those are easy to do in IronCAD. So fairly simple model to do in IronCAD, and we'll show a little bit of everything. So our drag and drop, some sketch creation, and show you how it's done in IronCAD a little bit differently. So we'll go ahead and move this over to another screen. And the first thing we're going to do is we're going to start with the slot feature in our standard starter catalog. And we'll go ahead and select on that feature. We know the width of that is 40 for the major difference there. And we know that the center to center is 18, but our handles, if you can see here on our link, they're on the outside. So we'll just actually select on these and set a value here that we know that it's 18 from the center to center plus our width, which is going to be the 40 on there. So we'll just put plus 40 inside there, and that will give us our base for our slot. We also have a height value, so we'll go ahead and set that height on that is 20. So we'll set that as our starting point. Next, we'll go ahead and do this angle shape here. And what I'm going to do is I'm going to rotate over here to the bottom. And we're going to select our part, and we're going to go ahead and do an extrude shape off of that. And what we're going to do is put a 2D profile right on the center point of our arc. So we want to use that point because that's a reference for our 105 dimension that we need to use. And this is showing our direction for our sketch with that little arrow, so that's fine. We're going to extrude that direction. And I have it set to hide all. You can display it so you can see this geometry, or you can hide it. That's just the display settings here you can use. But I do need to see it for a second because I do want to use this existing geometry. So I'm going to project that geometry as a construction element so I can see that it's there as a construction element. I can turn that off, and you can see if I hide everything, you can see that now I have those as a blue dashed line denoting that it's construction geometry. Next, what we want to do is we want to go ahead and do a polyline, and this is going to be real geometry. So we're going to do a polyline using the S key. I just access the polyline there, and I'm going to do a reference from my origin x-axis there, and I'm going to go up vertical here, a certain value. It doesn't really matter what that is right now, and I'm going to drag it over until I can see that tangency, that little blue item there on our curve, and I'm going to go straight down to the bottom here and hit this line again. So what you've seen up there are some dimensions we have, and I'll go ahead and turn those two off, and I'll explain those individually. So they come in handy here. But some things we want to do is we do want to make sure that this remains vertical here, and we do want to make a coincident of this point to this arc. And one of the reasons we want to do that is when you change this or remove this curve can move fully. And in doing so, if you don't have that coincident, the curve can move, and then you have to extend it back or trim it later, whatever. So what we're going to do is make sure it's coincident with that. So when this line changes, we'll get that information. So the next step, you can do this in multiple ways. I'm just going to show you a little bit an alternative way to build this versus traditionally using sketch dimensions, where you can put an angle sketch dimension on here and then a dimension from here to here and drive this curve, which you can easily do with our smart dimensions in IronCAD. But you don't always have to add dimensions in your sketches. It's not always a requirement that you find is in other CAD systems. So what I mean by that is those things that I had on before were these, what we call curve dimensions and endpoint dimensions. So curve dimensions are just exactly that. If I select on a curve, it's going to give me the length of that information and also the angle. So in this case, we know this angle has to be at 10 degree or 170 here because it's going to be a total of 20 on each side. So we're going to change that by just double clicking on that and typing 170. Now there's an option on here that's interesting. It says maintain end conditions. Okay, so what that means is it's got to maintain this tangency here, and it's got to maintain this height if that's on. So it actually wouldn't do this, or wouldn't allow this, because this height has to actually change. So we're just going to turn that off and say, go ahead and make that change. So it's going to move that height, change our 170, and maintain this because we have constraints on there. So that gives us our first part. So that's what curve dimensions do. But again, the curve dimension is this length here, which is not what I know. All I know is from this center point or this y-axis to here is a certain distance. So this won't do me any good. So that's what the other one option is, this endpoint dimensions. So endpoint dimensions, when you select on curves, it actually can, on either end of the curve, it can show you the endpoints from its references, which is in this case the x and y, but you can also move these to other references, which is really handy. If you have other geometry you want to refer to, you can use those as well. So in this case, we know this line is 102 right now, but we want that to be 105. And so we're going to set that to 105. But in this case, we do want to maintain the ending condition. So we do want to maintain this and this slope. So we're going to, when we hit 105 and hit OK, we can see now we've got our distance 105. We select on this, we still got our 170 inside of there. Without adding any constraints out here, we can do that easily within IronCAD's curve dimensions and sketch position dimensions. So next, we'll just go ahead and mirror this over to the other side. We can do this as a constraint or just a mirror command. Inside of here, we're going to select that curve and we're going to mirror it over to the other side and place that. And then we can extend these other two down, and you can just access that in our S key extend or on the ribbon bar up there. You can see it highlighted, but you can also see that it's given us what it's extending to. You can just hit tab to extend to another curve down and do so. So we can see we can extend to those two lines down to connect there. So that basically builds our profile very easy in IronCAD. Again, just a different way. We could have done it with sketch dimensions if we wanted to, but we didn't need to. We can also reverse our sketch, and we just set a value of 14 for the height of that and hit OK to go ahead and build that. So that's kind of how I built that angle here. And the next thing is our little extrusion here off the top. So this one's interesting as well because there's a couple unique things here because we don't know how deep this thing needs to go. So what I'm going to do is I'm going to drop my extrusion on here and I'm going to align it to the back here. And we know our width of this thing is 62, I believe. Let me double check that. Yeah, 62 millimeters there. So we're going to set that value and we're just going to pull this one in. And notice I don't have an actual point to snap to, so I can't really get the intersection point because there isn't an intersection point at this point at this time. So even at this case, if I try to snap back here, I can actually get the actual intersection point. So you can see that's one way to approach it is just to pull it past it so you get an intersection point and snap it back. So it's sort of like if you would have started in a sketch here, extruded the sketch up, and you could have actually just drew a line until it penetrated that curve, or that's coincident with that curve. Either way, but this is just a way to do it with our handles. It's just a fast way to pull it past and pull it back to get to that snap point. So that's one way to do that. The other thing that we know is this has an actual height on this, so we're going to edit the distance from a point from this bottom edge here. We know that height of this thing is 57 from the bottom to the very top, so we can set that. So that gives us our basis for this extrusion here. So next we'll go ahead and use our draft faces, and this will allow us to draft this face here 15 degrees, and we want to do the other side. We can rotate around or do Control Alt left click, which will bring up our geometry selector. In this case, we want to get this back face here as our other face that we want to add to that list, so we can select those two and go ahead and hit a draft on those. So we've got our draft for those two faces there. And now we know we have these little overhangs here, so we don't want these. And we don't have to create a sketch. We just grab that face, and we'll have a handle, and we can just pull that down to get that extrusion cut off there. So we can do that on both sides here. Grab the other one, pull it down to the other side. I don't really care how far. I'm just extruding it down. All right, so that gives us our basis for the shape, and now we have to deal with this taper on the back. So this one's actually fairly easy to do as well. So I'm going to rotate to the bottom, and what I'm going to do is I'm going to drop a through cut on this center point here. And simply just align it to this back face. And what I'm going to do is just rotate this thing. So how I'm going to rotate that is using the tri-ball. I'll pull the tri-ball up, and I'm going to snap it basically over to this location. That's where we're rotating about, essentially. And then I'm going to just rotate it over 15 degrees. And that will give me my shape for us just to pull our handle symmetrically to cut that extra geometry off. So that's a simple way to approach that. We don't have to do any extra draft planes or put an edge there, like for a parting edge or anything like that. To draft, we can just use an extra shape and just move it around. So this is kind of just the way we work in IronCAD. We just kind of think in 3D for this. So next, we're going to do all of our hole geometry inside of here. Again, you can do a lot of this stuff with sketches and other systems, and you can do so in IronCAD as well. Just trying to show you just some different ways to do this, just kind of thinking in 3D. So we have these through cuts here that we can just drag and drop out here. So in this case, we're going to extrude down here to cut this. We can snap to our face to align to this edge where we have our starting of our cut. Now we just need to do our references to these edges. So one thing we do again is right click to drag symmetrically, and I'm going to hold my shift key down to snap to this point, and that's going to get us aligned to that top edge. And we know it has an offset of 5 on each end, so we're just going to move our cursor to the end of that value and say subtract that 10, because I have no idea what that total value is. I just know that needs to be 5. Same for this one. I can just pull that handle and subtract 5 like this, or I can add a distance like we've shown earlier from point if you want to do it that way as well. In this case, I can just align that handle, subtract 5 from that, and I've got that value. So you can see that your values are correct. If you select down to the point or the edge here, it'll show you that length, which is 5 in those cases. And you can also select a face and an edge, and that'll also give you the distance there. So you can see that we're accurately setting this up just using our handles. Next, we're going to put a blend on here. So we have a blend value here for a value of 5. We have one on this edge as well. And we hit enter to apply those, and that gives us that basic shape. Next, let's go ahead and do our cut slot, which we have a shape for that already. We can drag and drop that out. Again, this one has a width of 25 inside of there, and a length, again, is going to be just that calculation, which we can just hit 18 plus, in this case, 25 to give us that value. And then we just pull our bottom handle all the way through or snap to the bottom face to get that cut. And then we'll use our extrude through cut again. So we can drag and drop that out, symmetrically pull our handle and type in the value they have here for 6 millimeters to get that little cut or notch going through there. So that's a very easy way to build that. Next are these two holes. So this is an interesting case. Most of the time they probably, most other systems would put a plane along the center line. They would draw it in the sketch to this point here and do some dimensions to this point to place that. And this is kind of your reference location, and to place this one in the sketch and then extrude both of those in one shape. I'm just going to show you how to do it again, just using our drag and drop, just another way to do this. And it gives you a little bit more power if you do it outside of the sketch, because you can move these features at any point anywhere else. So if you do it in the sketch, you're a little bit more confined on how you modify things. With these features, you're a lot easier to move things around. For example, I can just drop a through cylinder here, and the first one is the one on the top here is a 14 millimeter shape. And all I'm going to do is break my tri-ball, and I got my reference point. I can just now use this plane handle because I'm going to move in 2 directions. I want to move distance 1 and distance 2 is up. And when I right click and drag, I get an option to say move here, and I can type in those values. So in this case, we know distance 1 along is going to be 30, and it's going to go up 35. I'm just tabbing between those values, typing that, and I accurately place my hole. Next, I want to do another hole down here, so I can just turn my tri-ball off, do the same thing, or I could have copied it back down here and done it again. But anyways, I have my hole here, and it has a value of 9. And now I just do the same thing, tri-ball, same plane handle. It's basically just moving it in the plane direction of the tri-ball where it's sitting. Again, we'll just do the move here. And in this case, we're going to say we want to be 93 in the long value, and it's only 7 millimeters up to place that hole. So that's essentially very easy ways to place that in IronCAD. Again, these are individual features, so I can move these around, adjust their sizes easily. I don't have to go back into a sketch or use sketch dimensions to edit those. That's just an easy way to modify your geometry. So now if we go into our property browser, they have a density for this for 2700, and that will give us a total mass of 318 for this model. So very easy way to build this model in IronCAD. Again, multiple ways to build this. It's up to you, any user, to build it the way they want. This is showing you some new ways to do it in IronCAD.